Okay, today we're going to discuss tables of values with x and y pairs. Once we graph these coordinates, they should line up on a straight line. In a recent vlog, we had x values given to us in the table, and now there aren't any. Before you freak out, realize that you have control. You can pick any x value you'd like. Now, what I do is I pick easy numbers because I'm naturally lazy, and that works for me. The first number I usually almost always pick is 0. And I'll pick two other values, a positive number and a negative number, not necessarily the same number. As I see here, we'll have x times this negative 3 halves. And if I pick 2 for my x value, I know that my fraction will disappear. So I'm going to use positive 2 and negative 2. Let me make sure you see this, what's going on here. I have negative 3 halves times 0. Now we know anything times 0 is 0. So we should be thrilled right now. This makes it easier, doesn't it? So I'll do one more value right now, and then I'll give you an answer I already prepared. I suppose I'll do the negative 2. I'll replace negative 2 where x used to be, and we'll figure out the y value together. Now, most people don't like fractions, I understand. But multiplying fractions should become easier for you, if you understand how. I have negative 3 halves times a negative 2. Now, it isn't a fraction yet, but if I put 1 under there, it's a fraction. So now, all I have is straight multiplication, numerators and denominators. Some people here may know how to cancel, and if that's the case, when you cancel, you can look at the numerator or denominator and in pairs, wherever they may be. If the two numbers have similar divisors, meaning they're divided by the same thing without a remainder, evenly that is, I can see here that 2 will divide each of these numbers evenly. 2 divided by 2 is 1. 2 divided by negative 2, or negative 2 divided by 2, is negative 1. Now we can see we're going to multiply negative 3 with negative 1 and multiply 1 with 1. So what happens is negative 3 times negative 1, we have a negative and a negative. It's a positive. It's going to be positive 3. Now, as I said before, I already have finished this table and I have the answer for the remaining x value. Positive 2 goes with y value 0. Now I need to plot my 3 points on this graph right here. We need to label this graph first. The x-axis, the y-axis, the different scales. We're going to use x and y scale. Right now, it's a grid, but it's only a picture. It has 0 meaning right now. We need to label things so we have communication. Now, as we consider our scale, we can go up by 1, 1, 2, 3, 1, 2, 3. We can count by 2s, 2, 4, and 6. Now understand that your y scale and x scale don't have to be the same scale. You have to keep them uniform within each axis. I'm going to pick the boring scales and count up by 1 on both sides. Now this is enough. This tells me everything I need to know. I know where my axes are, I know what my scale is, and now I can graph. I'm going to graph my 3 pairs here, starting with 0, 3. Well, one of the cool things about using an electronic board like this is I can move things around if I've already written it and I don't like how it looks. So we have 3 points here on our graph, and it looks to be a straight line. And that means our answers are correct. Now you can see I added the arrows on both ends of the line because in reality this linear equation goes on forever. The line does not stop. Okay. If we kept going with this line, we could find many more answers than just these 3. We've picked these 3 to give a general picture of what the line looks like. Now I can find more x and y pairs that would satisfy this equation. I can go down here, and I can pick other points.